Welcome back, my friends, to the show that never ends. This will practice nothing stops the time sky. Welcome back, students. Welcome to my first video lesson remotely. Today we're going to talk about waves. So, back when I was in high school, I saw a video, and it was a famous scientist from the 20th century. His name was Buckminster Fuller, and he was doing a presentation on waves, and this video stuck with me. And I'm trying to recreate this video for you today. Basically, he was a philosopher and a scientist, and he was an inventor too. He invented the geodesic dome, and I'm going to show you a picture of what that looks like. Here's another one. It's basically a series of equilateral triangles set up in a hexagonal shape, and it forms a dome or a circle, and it doesn't need any internal supports at all. Probably the most famous geodesic dome is the one that you're familiar with. It's in Florida at Walt Disney World, and it's called Epcot Center, and that's what that one looks like. And I really like Buckminster Fuller. He was a genius, and he was underrated, of course. Here's my favorite expression from him. The wave is not the water. The water merely told us about the wave moving by. So I need you to imagine that it's a beautiful summer day. You're sitting on the edge of a community swimming pool and dangling your legs in the water. You can feel the waves created by all the other people in the pool lapping against your legs. Now imagine you're wearing eye shades and earplugs so that you can't hear or see anything. All you can feel are the water waves striking against your legs. You have limited information coming into your brain because you can't see or hear anything, but you can feel the waves. You can tell something about the waves. You can feel how fast they're coming in. You can feel how often they're coming in. You can feel how strong the waves are by how hard they hit your legs. You can probably feel how high the waves are as well, but that's all. You only have access to a limited amount of information. You're limited by your senses. Now imagine that the waves are magical and can overcome your sensory limitations. Picture the waves coming toward you and striking you, but this time the waves are giving you more information about what is going on in the pool. Amazingly, the waves can tell you how many people are in the pool. Also, the waves are telling you where those people are in relation to your position. The waves are telling you how hot the sun is, how cold the water is, what color the sky is, what time of day it is, if it looks like it's going to storm later, who's dunking their little brother's head under the water, and if you need to apply more sunscreen. But there's more. The waves are also telling you everything else that is going on around you. The splash of a diver, the screech of a kindergartner, a mom yelling at little Billy to stop splashing the water into your sister's face, the cry of a seagull, the sound of the wind through the nearby trees. Suddenly, you're getting all kinds of information from the waves reaching you. It's like magic. No, it's not magic. It's science. It's how you interpret and see, hear, and feel the world around you. It's waves. It's light waves that let you see everything going on around you. It's sound waves that let you hear everything going on around you. It's infrared waves that let you feel the sun on your back and the cold water on your toes. It's ultraviolet waves that give you that deep tropical suntan, or sunburn if you aren't careful. It's water waves that let you feel the rhythmic pulses from kids jumping in the pool. Waves are responsible for giving you the opportunity to experience the universe. So what's the whole point of this story, you ask? The point is, waves not only transmit energy, they transmit information. Not just light waves, sound waves, and water waves, but every single type of wave that we've discovered so far. In this lesson, we will discuss the types of waves and the categories in which they belong. Then, during the next video lesson, we'll discuss the properties and characteristics that different types of waves share. Waves can be categorized in many ways. The two main types of waves are longitudinal waves and transverse waves. They are described by the direction of their motion and the direction of the energy that they're transmitting. Let's look at this demonstration to compare and analyze the structure of these two types of waves. The first wave I want to show you is a longitudinal wave. In a longitudinal wave, the direction of motion in the wave is the same as the direction of the energy being transmitted. Let's take a look. This is a type of longitudinal wave called a compression wave. Notice as I compress the spring sections and release them, the compression is sent throughout the spring. But the spring doesn't move. It's still attached at one end to my hand and the other end to the table. Only the energy that was released is transmitted through the spring. Otherwise, if I let go, the whole spring would go flying right outside the garage. As you can see, the energy is traveling in the same direction as the wave motion, back and forth in a straight line only. This is what defines a longitudinal wave. Sound waves are longitudinal compressional waves. Remember, longitude has the word long in it, the root word long, as in a straight line going a long way back and forth in only two directions. Now I'm going to set up my equipment to show you a transverse wave using a different slinky spring. You may have done these types of tricks with a jump rope when you were younger. Okay, I'm set up with a long slinky to show the transverse wave. We used to call it crack the whip. As you can see, when I snap the spring, it causes a wave to move down the spring. Notice that the spring itself did not move. I'm still holding on to it with my hand, and it's still attached to the garage door handle. Only the energy of the wave moved through the spring. However, in this transverse wave, the energy went in a straight line down towards the garage door, but the motion of the wave was up and down, like this. Up and down. I can also show you side to side, and maybe you'll get a better view. Now, if I add continual motion, watch what happens. So basically, I've just added more waves by using a repeated pattern, an oscillation or a vibration. And it's starting to look like a wave in water when you do it this way. That's because a water wave is a transverse wave. The energy goes towards the shore, but the wave motion goes up and down. Finally, I want to show you a special type of transverse wave. Let me set it up real quick. So finally, I'm going to show you a special type of transverse wave. It's called an electromagnetic wave. It's difficult to show the actual motion with this spring because a real electromagnetic wave is invisible. And because it's electromagnetic, it has both an electric field and a magnetic field. And the fields are at right angles to one another. It's a three-dimensional field. I would need to somehow glue two of these springs together at right angles to accurately show this phenomenon. And, that ain't going to happen. So instead, I'm going to try to show you a representation of what an electromagnetic wave looks like. Here's a transverse electromagnetic wave. Notice how the wave moves in a circular motion, simulating how the electric and magnetic fields are traveling in three dimensions. Simply amazing, isn't it? You may have noticed other characteristics of waves being illustrated during these demonstrations. Perhaps you noticed that some waves were shorter, some were longer, some were higher than others during these manipulations. Well, that's going to be for another lesson. We'll discuss the characteristics of those waves during next week's video lesson. So I'm going to play with this for another minute. Please don't forget to submit your answers to the questions I put on Google Classroom today. Love the sound effects. So that's it for today. Thanks for listening. Thanks for watching. Thanks for learning. Miss you guys. Don't worry. Be happy. Tune in next week for another fascinating and exciting episode of Bry the Science Guy.